Hi class, in lesson 8.1 we will be looking at relationships between quantities. Learning targets for today, we will be predicting the next term in a sequence and writing numerical and algebraic expressions. A couple of key terms to look for in this lesson will be sequence and term. Let's take a look at problem 1 on page 532, building trains. It says that Josh likes building trains out of train parts. Each train car needs 4 wheels. Josh begins by building a train with 1 car, then 2 cars, and finally 3 cars as shown. Take a look at number 1. It says describe how many total wheels Josh will need to build a train with 4 cars. How many total wheels will he need to build a train with 5 cars? Go ahead and answer number 1. If we look at 4 cars first, Josh will need 16 wheels to build a train with 4 cars, and Josh will need 20 wheels in order to build a train with 5 cars. A sequence is a pattern involving an ordered arrangement of numbers, geometric figures, letters, or other objects. The number of train cars and the number of wheels needed form sequences of numbers. Take a look at number 2. It says to write 2 sequences then using Josh's train cars. 1 for the number of cars and 1 for the number of wheels. The sequence for the number of cars would be 1, 2, 3, 4. And the sequence for the number of wheels would be 4, 8, 12, 16. If we take a look at the top of page 533, it says that each number of cars in the first sequence and each number of wheels in the second sequence form the terms or members of the sequence. A term is a number, a variable, or a product of numbers and variables. The first term is the first object or number in the sequence. The second term is the second object or number in the sequence, and so on. So go ahead and answer numbers 3 through 6 on page 533. If we take a look at number 3, the first term in the second sequence would be 4. Remember, we are referring back to the number of wheels that Josh has for his train cars. For number 4, the fifth term in the first sequence, we are talking about the number of cars for Josh's train cars now. The fifth term would be 5. The 2 quantities that are changing are the number of cars and the number of wheels for number 5. For number 6, explain how you would determine the number of wheels needed to make a train with 6, 7, and 8 cars. You know that 5 cars require a total of 20 wheels, so you can just keep adding 4 to the total of 20 wheels. Each time that you add another car, you're adding 4 to that total number of wheels. So for 6 cars, you would add 4 to 20. For 7 cars, you would add 8. And for 8 cars, you would add 12. Let's take a look at number 7 and number 8. Describe in your own words how to calculate the number of wheels needed if the train has any number of cars. You can go ahead and think about that variable on your own to use for number 8 then when you have to write an algebraic expression to represent the number of wheels needed to build a train with an unknown number of cars. All you would have to do then for number 7 is multiply the number of cars by 4 in order to calculate the total number of wheels. The algebraic expression then would be represented as 4 times n or 4n. And again, you could have used whatever variable you wanted to for this situation. Let's take a look at a different problem situation with Josh at the top of page 534. Josh would like to add more trains to his collection. The cost of each car is $8. So based off of that problem situation, let's start off by answering letters A through D. The sequence for letter A that you should have written down is going to be $8, $16, $24, $32, and $40. That's going to be the cost of buying 1, 2, 3, 4, and 5 cars. For letter B, the mathematical process that is being repeated, you are adding 8 to the sum each time in order to determine what the cost is of each new set of cars. For letter C, what are the variable quantities or the quantities that are changing? In this particular situation, it's the number of cars to purchase and the cost in dollars in order to buy the cars that are changing each time. For letter D, the quantity that is remaining the same or the constant is going to be the cost of each train car, which is $8 per car. Let's finish up the bottom of page 534 by answering letter E and letter F. Which variable quantity depends on the other variable quantity? And for letter F, write an algebraic expression for the total cost in dollars for a train set with N cars. And then it also tells us to rewrite the first 5 terms of the sequence. So go ahead and do letter E and letter F. For letter E, the total cost of the cars is going to depend on how many cars will be purchased. For letter F, the algebraic expression that we should be looking for is 8n, which is 8 times the number of cars. The cost of the cars then, again, $8, $16, $24, $32, and $40. Let's take a look at the top of page 535. Number 10 says to write an algebraic expression to represent each sequence. Sometimes creating a term table may be helpful for us in order to take a look at the relationship between the term number and the term when we have to write an algebraic expression. So let's look at letter A together, and if you want to use a term table in order to help you figure out the algebraic expressions for B through E, you can go ahead and do that. So let's look at letter A together. So for letter A, I have the numbers 2, 4, 6, and 8, which form my sequence. I want to take a look at the total number. I want to take a look at how many total numbers are in my sequence, and that would be my term numbers that I label in the top of my table. So I can see that I have 4 total numbers. So 1, 2, 3, 4 would be how I label the top row of my term table. Now I'm going to look at the terms that are in my sequence. The first number is a 2, the second number is a 4, the third number is a 6, and the fourth number is an 8. Now in order to come up with an algebraic expression, I want to take a look at the relationship between the term number and the term for each number in the sequence. So what am I doing to the term number in order to get the term in each of the numbers in the sequence? In this particular example, I'm taking the term number and I am multiplying it by 2 in order to get the term. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So my algebraic expression then to represent this sequence of numbers would be 2 times n. If I think back to problem number 9 and Josh wanting to add more trains to his collection, the cost of each car would be $8. The sequence that would represent the cost of buying 1, 2, 3, 4, and 5 cars. So if you take a look at creating a term table for this example as well to help you figure out an algebraic expression, what are we doing to the term number in order to get the term? In each case, we are multiplying 1 times 8, 2 times 8, 3 times 8, 4 times 8, and 5 times 8 in order to get the cost of the cars. So let's take a look at letter B. We have the numbers 1, 3, 5, and 7 that are representing the sequence. Let's go ahead and come up with an algebraic expression for this. Again, I have 4 numbers in my sequence. The first number is a 1, the second number is a 3, the third number is a 5, and the fourth number is a 7. So what relationship does the term number and the term, what relationship do those two numbers have? What am I doing to the term number in order to get the term? That will help you figure out what your algebraic expression should be for letter B. Letter B was a little tougher. We actually had to incorporate two different operations. We had to multiply and subtract. If I take a look at my first term is 1, I have to multiply by 2, and then I have to subtract by 1. And I'm doing that for every single term that is in my sequence. So the algebraic expression for letter B is going to be 2n minus 1. Here are what your algebraic expressions should look like for letters C, D, and E. Again, if you use term tables to help you figure that out. For letter C, you should have 2n plus 1. For letter D, 2 to the power of n. And for letter E, n plus 100 would be your algebraic expression. Let's take a look at problem 2 at the bottom of page 535, parts of algebraic expressions. As you learned previously, an algebraic expression contains at least one variable and sometimes numbers and operations. A term of an algebraic expression is a number, variable, or product of numbers and variables. So let's take a look at the example and consider the expression 3x plus 4y minus 7. This particular expression has three terms based off of that definition. 3x would be one, 4y would be another, and 7 would be the final term. The operations that I see are addition and subtraction. Now remember, 3x is a term because it is the product of a number and a variable along with 4y, and 7 is just a number, so that would also be considered a term in that algebraic expression. Let's take a look at number 1 at the top of page 536 and consider two algebraic expressions. We have 8 plus 5x and we have 8 minus 5x. I would like you to do letters A through E for number 1 based off of the example that we just had a look at on page 536. If we take a look at number 1, each algebraic expression has two terms. For letter B, the first expression contains addition, the second one contains subtraction. For letter C, the terms are the same in both expressions. The first term is 8 and the second term is 5x. The number of terms and the terms themselves are the same in both expressions, and the only thing that is different is the operations for letter E. Let's look at number 2, identify the number of terms and then the terms themselves for each algebraic expression. Go ahead and do letters A, B, and C. For letter A, we have two terms, 4 and 3x. For letter B, there would be three terms, 4a, 9, and 3a. And for letter C, we would have four terms, 7b, 9x, 3a, and 12. Homework for lesson 8.1, we are going to take a look at number 3. You need to write an algebraic expression that represents each situation. So go ahead and do letters A through G. And I also want you to do number 4 for homework as well. Write an algebraic expression that represents each word expression, letters A through H for number 4. That is it for lesson 8.1, relationships between quantities, looking at algebraic expressions. Please let me know if you have any questions. Thanks.